Hey everyone, this is probably going to be a slightly different presentation to some of them you've seen today, although we are going to get some code out and do some other things. That code's not wholly going to be Java-based, which will probably be a bit of a deviation from the norm. I'm also aware that I'm going to be holding everyone away from their beer allocation this evening, so I'm hoping I'm not going to run over and this will all go very smoothly. The presentation I'm talking about today isn't really related to much of the stuff we do as a company. We're involved in IoT connectivity, but what we do find in anything to do with the IoT world is you get your fingers involved in all kinds of things you never expected to. I know more about battery chemistry now than I ever wanted to know, and you often find situations where customers of ours are wanting to prototype things, and often in edge gateways. Now, there are lots of commercially available edge gateways, and there are lots of commercially available edge gateway software stacks. So, for example, if you go down and see the guys at Eurotech, you'll find that they're using the Eclipse Cura stack on their edge devices, and that's obviously available for other people to use. You've got things like the Bosch IoT edge stack as well, which is similarly based on OSGI. So there is a large collection of components that have been developed by people already for use in IoT purposes on the edge. And they're pretty hard, they're robust, they're covering all kinds of use cases, including talking to other protocols, talking to devices that are hanging off these edge controllers. But equally, to use that stuff, you actually have to write real code, which for a lot of people in terms of rapid prototyping is not necessarily what they want to do. They want to have something that they can prove something quite quickly. And so Node-RED is a project that originates in IBM and is great for prototyping things. Again, there's a wide range of communication protocols, drivers, a bunch of other plugins that are available for Node-RED. It's not necessarily something you'd want to put into production where you want things to be super robust, but if you want to turn out a demo very quickly, it's great. You can often do things in a matter of minutes because really there's no code involved in doing it. And just to show you the difference between the two, is in terms of a developer's environment, a typical kind of OSGI approach to writing some code versus drag some nodes, configure them, hang them together, you're done. Now, what we wanted to do is try and square that circle to give people the kind of ability to do this sort of thing, but using components that perhaps they created themselves, or that people like Bosch and open source projects like Cura had already created and existed in the OSGI space. That was the problem. How do you combine those two very different worlds? You've got Node-RED, which is JavaScript, runs in the V8 virtual machine using Node.js, and then you've got OSGI, runs on the Java virtual machine. Now, when we were looking at this, there are obviously things like bindings as part of the javax.script extensions to allow you to run JavaScript within the Java virtual machine. But that was not really necessarily going to be reliable enough to run Node-RED, which obviously is based on Node.js. However, there is an Eclipse source project we found called J2V8, which was created by a guy called Ian Bell, which was originally developed for running, as it says here, a project called Tabris.js, which is basically a development environment for Android. It allows you to create applications in JavaScript that will run on Android and look like native mode applications. And it basically exposes the V8 virtual machine that's in Android out to the runtime to allow you to do stuff and build applications. Now, that looked like it had interesting promise. It was something that you could invoke and create from within Java, and therefore you could do stuff with it, and it provided a series of bindings, much like the javax.script extensions, that allows you to interoperate between the two worlds. So the first question was, does it actually work? Well, yes. A simple test, just a quick sort of prototype of a main and not much else, demonstrated that you could instantiate the V8 virtual machine and run Node-RED in it. That was a pretty easy example. Then turning that into an OSGI bundle and service also wasn't particularly difficult. Now, for our particular purposes, there are some modifications that we had to do at a native level because typically the target for that platform originally was, as I said, Android. So Android and ARM was a good combination. x86 and Linux was supported. But what we really wanted, which was ARM and Linux, wasn't supported. So we had to do a little bit of work to port the V8 virtual machine onto that target architecture and then recompile all of the native bindings to produce ourselves a native library that would actually do the job. But it wasn't too hard. And then obviously what we needed to create was some bridging code that allowed us to make OSGI or expose OSGI services to something that could be consumed inside the Node-RED environment. So just a quick aside about how J2V8 works. It essentially has two different sets of functions. One that allows you to create, if you look at this diagram here on the right, you've got these three worlds, Java, the bindings, and then the JavaScript world. It allows you to create objects, representations in the Java world, and then either export or import them into JavaScript. So you can take an object of some type, like an integer, export it, and then you'll see it as an integer with the same variable name in the JavaScript world. You can also do the same thing with objects, and you can also do the same thing with functions. So you can take Java functions that live within an object, methods within an object, and expose them as JavaScript functions. So for example, here, you might take a method inside an object like getFoo, expose it as a function inside JavaScript. Now, generally, those things, if you did that with JavaScript, would be global to JavaScript. But part of the intention of this was to try and make, by using the V8 virtual machine in a certain way, you can modularize these things, so you don't end up having functions with the same name potentially exposed all over the place as with namespace collisions. You can also then do the same thing backwards. So in this instance, any JavaScript function calling getFoo will end up calling back onto your object. And you can do the same thing in the opposite direction, where you can make Java call back methods in JavaScript. So the next job of work is really then to take what you have and create a wrapper for it, a service wrapper, that represents the same lifecycle that is represented in Node-RED. Now, there are a number of things that when you see Node-RED, to make them visually look like they are, there are obviously some layout style elements in terms of colors, in terms of fonts, descriptions, that kind of stuff. But the basics of what happens are three methods, really. An onCreate, so that's when the flow, if you like, is deployed onto the runtime. There's two elements to Node-RED. There's the Visual Composer, and then you actually deploy it, and that's when it sits in the runtime active. When that happens, it calls essentially an onCreate function, which you can map in Java with something like this. A close, which is the opposite, when you kill off that flow. And then a message. Basically, Node-RED is working by sending messages down that pipeline, down through that flow, into this function. Now, in flows, one message arrives, this one, but you'll notice it returns an array because you can have multiple outs from a single message, so you can break it into multiple copies. And they can be different types of messages, so you have flexibility of one message coming in and then being split with different things going down. Now, for this, we wanted something, obviously, to represent the data model between the two. So in this case, I chose to use Jackson, just because Jackson's JSON node functions are pretty generic, widely used everywhere, easy and simple for the task. So what I'll do is now show you a couple of examples of this working. A simple node component, which just has a one in, one out, and does some data processing, and then something a bit more complicated that wraps an existing Java library into something that shows a bit of reuse. So, first thing I'm just going to do here, what I've got running down here in this window is just Felix, so nothing special there, but you can see by default it's just got a bunch of pretty standard bundles installed into the framework, nothing exciting there. I'm going to stop that, and then over here I'm just going to export a collection of bundles into that runtime. Okay. So if I run that up now, you'll notice the startup is going to be a bit different. So there's a bunch of additional stuff that's happening here as it's installing and running Node-RED from within a bundle. So we've taken the whole of the V8 runtime, the whole of Node-RED, packaged them both as bundles. So this Mac does not have to have any other Node-RED components in it. It's all self-contained within the OSGI bundles. Now that's done, we can bring up the Node-RED UI. So this is now Node-RED running within a Java, being started from the Java virtual machine and being controlled by the OSGI framework. So if I take a simple example here of taking just a trigger and attaching it to a debug node, I can make some adjustments to properties in here. So for example, let's have it, make it an interval of say 30 seconds. Inject at start, done, and deploy. You will see in the debug tab, every 30 seconds you'll see a print here just of a timeout. So I'm now going to stop that. So for the first of these demonstrations, what I'm going to show you is a simple example. So what we've done here, as you can see, it's just a regular OSGI component using DS with a bunch of properties at the top of it. I'm going to move over the node definition stuff because it's a chunky bit of code, but looking in it, you can see basically this is a Java object that represents the colors, the fonts, all the stuff that's appearing in that visual editor. Then we've got some stuff in here for the various elements on onCreate that set some settings. They read some settings that we set up in the top properties and apply them to the actual elements that we're using. And then in the case of the onMessage, we simply get the payload out of the message, do a conversion on it, and send it back into the downstream flow. So if I deploy all that stuff, one moment. So here we have our flow again. I'm now going to edit that up. Oh, sorry. Should we reload that? Yep. So we added that component down in the function section, and there it is. I can drag that in here now. I can connect it up. I can make some changes to it. So the part of, again, what that you saw in that Java metadata allowed me to change things. So if I change it to long, for example, and say done, and then deploy it, what we should see now is it's changing the format to the long date format. So what we've got here is a simple component dropped in that shows you a service developed in OSGI that's now interoperating with the rest of that, the Node-RED function. And every 30 seconds, you'll see that update and complete its next things. So the more complicated example that I have is taking something that already exists, which is the Parho client for MQTT. Now, Node-RED does have its own MQTT client, but this is just a simple example that shows the use of something a bit more complex. Some of this stuff I could have exposed as properties, but I just couldn't, going through the pain of writing or putting together the node description to expose all that stuff just wasn't worth it for the purpose of the demo, but it does allow me to modify which topic that I can set on each of the values. Again, the activate and deactivate are pretty straightforward. And then the key thing is what happens when you have a message, which is essentially, well, actually, this is a slightly different component. The key thing about this component is it's at the left-hand side of the publishing flow. So this originates at messages going into the flow. So rather than arriving with an on message being called, it actually has to originate things into Node-RED. And that's what this does. So you have a standard Parho callback that gets called when MQTT messages arrive into Parho. And then this basically creates a payload, a brand new message for Node-RED. And then this function, mc.createMessage, is basically what injects it into that flow to start the flow off. So if I now export that, we now have the MQTT subscriber node. Something that's interesting that I could have shown you there is actually that the system is entirely dynamic. Just OSGI is dynamic, but so is Node-RED. So actually, as you deploy components, if I had the command line done an installed the jar, kicked it off, the component would have appeared dynamically in the menu. So it doesn't require a complete fresh boot to do this. You can add, remove components dynamically within the flows. So in this particular example, what I'm going to do now is just remove a couple of these, drag that over here. I'm going to subscribe this to a topic. And deploy that. Stick that on debug now. Over here I have MQTT box. So if I connect that up, this is just a simple browser-based MQTT client. So if I now hit publish, it's published that to the topic, and I should see. Now I have to not promise you that the Wi-Fi is working because everyone's been having trouble today, so hopefully. Yeah. Right. Okay, great. How annoying. Yeah, I have no idea why I'm not seeing that message. Anyway, you get the idea, I think. So that's a couple of examples. So then, having done that, that solved most of the questions that our customers have. Could you actually build stuff that allows people to reuse their MQTT or their components they have written in for OSGI and mix the two environments? And the answer is yes, you can. And it's quite easy to deploy. People haven't got to go around to the trouble of having to find or deploy Node.js and then Node-RED on top of that and all the rest of that stuff. You can just deploy it as a couple of bundles and you're done. And actually, it's a really good use for bundle fragments in a strange way, because obviously the native libraries of that fit into very nicely with the pattern of being able to have separate fragments, bundle fragments for the different versions of native libraries for x86, ARM, x86, Linux, ... all the rest of the things you need to do. But out of curiosity, the question then was, could you do this the other way around? Could you create services, OSGI services, entirely written in JavaScript? So that was just an interesting side project rather than being something that was the purpose of doing it. And the answer to that is, yes, you can. So what I'll do now is show something that works the other way around. So we built a simple component that basically works very similarly to the DS component registry, but actually works based on JavaScript objects that have been created and wrapped and made to look like bundles. It basically operates using a lot of reflection by looking at the service interfaces that need to be created, creates dynamic proxies for those, maps those by exporting their Java methods back to the JavaScript runtime and vice versa, to allow you to have services created in JavaScript that work within the OSGI space. So what I'm going to do for this is just to switch workspace. Okay, so in this example here, all I've done is created a service interface, an OSGI service interface that's pretty simple, says hello, takes an input, returns a string, very simple. And then I've written a caller to that, which is using, again, DS with 1.3 annotations to provide references both to the OSGI log service and also something that's going to implement the MyService interface. And when it finds it, obviously the activate will get hit because it's waiting on that reference, at which point it'll print a bit of logging, and it will call MyService, say hello, passing in foobar, and then we'll log out the message that comes back from whatever service it is. Now, what I'll also show you in here is, if I can remember where I put it, here we go, this is it. So something that we created to map this. So what we have here is a manifest that looks pretty similar to most OSGI manifests. Uses the same import package, so there are certain services being imported by this object. They are obviously OSGI services, the test interface, and also the logging service. So just like the fact that even though this is not a Java object, this is going to be a JavaScript component, we're using the same import packages to make only those objects and those namespaces available within the JavaScript runtime. Now, we are using an extension here for JS component that allows us to specify basically which piece of JavaScript declares a component that implements various things. So if I now go and have a look at that, you can see something that looks very similar to, can we get that a bit bigger, I wonder? No, you can't. Something that looks very similar to the XML for a component description, albeit that's written in JavaScript for simplicity. So the same sort of thing, you've got all of the activation parameters, which functions are going to be called on activate, deactivate, what service this implements, in this case, what's the name of the component, and also service references from the Java world back to OSGI. Sorry, from the JavaScript world to OSGI. So this is the same type of dependency mapping that you would get. Finally, let's just have a quick look at the JavaScript component itself. Not much in it, it's just a bunch of properties. The two functions, activate and deactivate, that are declared for the activator and deactivator for the OSGI component don't do anything in this case, but we do implement the say hello function. And you'll also notice in that binding for the component, we required the log service with a name for it. And you'll see here that the logger, the name of the variable, is being used in that JavaScript function, even though there's no definition for how that's going to work. So that mapping of how that creates and all the functions are going to happen dynamically when we deploy the component. So let's just give this a go. So what I'm going to do is just run up the framework. Now, there's nothing in here at the moment, so if I get a list of the bundles, you can see it's basically the services that we have created there, but not the JavaScript component, have been deployed, so the runtimes, etc., are all in here. What I'm now going to do is install the bundle. So I've created that JavaScript set of components I've jarred it up. I've just installed it. You can see the bundle ID 17. Now what I'm going to do is start that, and you will be able to see just what happens, because obviously there's currently nothing that's satisfying the dependent. In fact, actually, okay. If I take a look at that, you'll see the test caller is currently not active because there's nothing that satisfies the reference. So if I now start this bundle, so you see immediately it processed the component, got the data for it, did all the reflection, created the dynamic proxies, etc. for that, called it, in say hello, that's the message that came out of the service function, but you'll notice that also came out via the log service back into the console. So what that demonstrated is not only did we inject an OSGI service into the JavaScript runtime that got called right there, we also were able to create a component in JavaScript that was active now in the OSGI world. So you can now combine the two. Now, how useful that is to people is a questionable thing. In fact, I've never been a JavaScript programmer, and until fairly recently, this is the first experience I've ever had of it. And it certainly has, for some people, it's easy in that you can script this stuff up, and so it's quick and easy to write code very often. It has some quite severe limitations, in my view, in terms of things like a fairly limited platform. Thread support is fairly limited, so doing what you can do with it is limited, but it's an interesting, potentially first step in broadening the support. Now, when we first looked at this, thought that it was something that it would be interesting to show to people at an event like this. Now, obviously, we've done this using J2V8. Now, obviously, you have components like GraalVM. There's no reason why you shouldn't implement this on GraalVM, and in fact, the implementation we did here, for this example, i.e. the JavaScript component, was done deliberately with a layer in between the J2V8 implementation and the JavaScript function. So we interface them apart, so you could replace it with something else. So replacing it with a different implementation of the JavaScript runtime, if you wanted to do that in Graal, is just a case of writing a different binding. The interface layer is exactly the same. Thank you.